Here are two component packages. Do they look the same? But what if you examine them from the inside? Can you see the difference? Counterfeit electronic components are substitutes or unauthorized copies of a product. In such counterfeits, the materials used or the performance of the product can be changed without any obvious difference on the outside, or a substandard component can be misrepresented by the supplier. Counterfeit electronic components nowadays are a growing issue to the electronics industry. The consequential costs to electronics manufacturers of inadvertently purchasing counterfeit components include lost yield, field failures, product recalls, damage to reputation, and more. Not to mention the safety issues. But is there a solution? ChipCheck. It's exactly what the solution should be. An initiative to ensure that electronics chips used in millions of electronic appliances every day are exactly what they say they are: genuine, not secondhand, not defective, not worn out, and above all, not counterfeit. Funded by the European Commission, the ChipCheck Consortium has developed a novel micro-mini focus real-time X-ray inspection system for fast automated detection of counterfeit PCB components, a system which is suitable for use at good inwards. Enabled through the development, enhancement, and unique combination of various X-ray technologies used in different industries, for example NTD industrial, medical, and dentistry, a pre-production prototype fully validated by the consortium SMEs is already developed and ready to provide its services to the European as well as the global electronics industry.
These are components which are typically misrepresented fake chips made to look like a genuine component. Why is a counterfeit component an issue? Well, just imagine if you had a counterfeit component which got into the supply chain that supplied a manufacturer of aeroplanes, for example. If you had a counterfeit component in the control command for an aeroplane, if that chip doesn't function properly or doesn't function at all or suddenly fails, that could result in a life-threatening situation. Equally, you can have a counterfeit component that could be used in the control station of a nuclear power station. So those are life-threatening, but also you can have more like traditional products, commercial products, for example, a phone or an MP3 player. It's not necessarily a safety issue, but if the component suddenly misbehaves due to being counterfeit, it could cause the product to completely fail. That could be a very expensive situation for the manufacturer. It could involve an expensive product recall, but also result in loss of reputation.
The ChipCheck system provides automatic inspection of components supplied on tape and reel, waffle trays, and tubes by simply changing the ChipCheck feeder module. This system is also capable of inspecting complete PCBs.
So shift to another type of reel, you open the machine, and the machine is secured by interlock system. Right position. The number of chips on those wheels depend of course of the size of the chips, but this particular one is containing 100 samples. It could be up to 1,000 on one wheel.
Below here we have the X-ray source, produces X-ray and sends it through the microchips which are located on this tape. The X-ray goes to this detector which are located here. It collects the pictures and sends them to the computer for inspection. And the chips are then moving forward like this. The system is driven by stepper motors which are located at the behind here and over there.
The total European electronics annual production is worth around 226 billion euros. It can be derived that counterfeit components could therefore be costing the electronics industry up to 11.3 billion euros a year, or 5%. The situation with counterfeit components is not just an economic issue, but also a safety one. In the consumer electronics industry, there have been reports of products exploding as a result of counterfeit components. The successful commercialization of the ChipCheck prototype in the years to come by the participating SMEs will enable an industry-standard automated inspection technique to be adopted by the electronics industry. The advancement beyond the current state-of-the-art will offer the inspection capability required by the consortium SMEs and wider industry SMEs to realize a competitive advantage in this market segment.